I think we are before time. 6 minutes to uh, take a break, rest, relax, soak in what was just said. Um, Thank you so much, KCC. Thank you so much, Kolkata. Uh, this used to be and is perhaps one of my favorite Indian cities. I've been here as a child. My aunt, my father's sister, she was an artist living on Waterloo Street, so I spent some significant vacations over here. So thank you so much for inviting me. Should we commence or should we wait for the time? It's 5 minutes. I think there was a very interesting question that came about building an environment, and I just want to kind of go back to also the email which I, received from KCC about about what should I speak on. I mean, I do a range of things, and there was this idea of intersectionality. There was the idea of art, craft, design, architecture, exhibition, landscape. I mean, it's just a wide range of experiences. Academia, I am also a dean at the Faculty of Design, CEPT University. Can we have the mobile phones switched off? Okay. Um, so there was this one note which said, your perspective on creativity's role in promoting environmental sustainability. And there was this question that came up, the last question actually, on architecture, environment, and building for that. And I thought it might be interesting that I bring in circularity. And circularity is a significant word which is coming into fore recently. The 21st century, and I'm pulling out from a part of my convocation speech a year back, that the 21st century demands that you carefully construct and amplify the human experience. With the projected population of 8.5 billion by 2030, it demands that you work at efficiencies of scale unlike at any other point of time. And that's where we are at this point on global level. It demands that you deliver efficiencies, whether in resources, in processes, or in budgets, as was just recently pointed out. You will, of course, need to make delicate choices between human convenience and environmental convenience. And that I felt was, that is coming into discussion on a daily basis nowadays. In fact, radical perspectives have emerged. And these are compelling perspectives, and this is about an argument that instead of creating, better, innovative, sustainable solutions, products, landscapes, architecture, it is to just stop designing new things altogether and to focus on maintenance. I mean, this is the kind of discourse that is present today, and I'm happy that you, in fact, this young generation will perhaps add to it, bring value to it, perhaps even contribute significantly to it. And you will have no choice, actually, because what generations before have done, you will have to work with the consequences. So maybe I can begin my formal presentation. We have 1 minute more, but let's begin. Circularity by design. And a short note, I just want to, in the beginning, the images are stretched vertically. It impacts my sensibility as a designer, but that's the nature of technology. So that's just bear with that. So what I thought may be interesting for perhaps an audience like this is to speak about circularity, one from design pedagogy and other from practice. And so it's fundamental in the way I also work. One is a postgraduate studio project where I was a lead tutor, and the other is from our practice case design based in Mumbai. A series of exhibitions we did, which incidentally, one of them had also, I mean, in a prior form was also at KCC. I'll come to that. So the idea was academic research guides the former, and I will show you the kind of research students did and we did together. The intuitive and the tacit were part of the discourse when we were designing these exhibitions. And there were responses to circular frameworks, and there are very many responses to circular frameworks, and we'll talk about this. And what then are the tangible outcomes, whether in form, in aesthetics, in detail, in materiality, and that's perhaps what I'll bring about today. So thank you so much for the next 45 minutes or so. Okay, there's something here. CEPT, for those who've not been there, I do hope you can make it sometime. But this is where I work half the month. I'm the professor and dean of the Faculty of Design. The Faculty of Design is in a transformative space. Soon we'll have students who are in product and communication, graduating, filmmakers, animators, photographers, product designers, furniture designers. That's the work I do at CEPT. This is our studio, Case Design. We are a large studio. We work on all kinds of projects. That's at Case Design. Just a brief introduction. And then we jump straight in. And I'd like to begin with this idea of environment. Maybe difficult for you to read everything. Let me know if it's this thing. But what you're seeing over here, and I'm going to have to orient myself a bit, is the relentless rise of carbon dioxide. And that's what everyone is talking about specifically. So what you're seeing over here, and is there a pointer? Is there a pointer here? If you look at the span of is the pointer? Yes. It's working? It's okay, no problem. If you look at the span of human existence, or let's say the Earth's existence, you have 800,000 and you have 0. 0 is at 1950. For millennia, atmospheric carbon dioxide had never been above this line. And what is this line? This line is around the 300 level. And what happens then post 1950? What happens to this carbon dioxide? It almost shoots up vertically. And that when you see in a more broader way from 1950 onwards over here, and you see 2022 over here, you will see the graph, right? How consequential is this? And there have been discussions by environmentalists, which are earlier there were side discussions, now there are more forceful engagements and perhaps more vocal statements and more researched statements on this matter. Sorry. Oops. It's a bit, okay, so there we are. In the consequence of carbon, I showed you this wide graph. Yeah, thanks. front and back. Yeah. It's okay, I'll make it work. The tool has gone away. But, emissions rose, there's been the significant data. It seems like a massive rise, but what is the real situation? And I'm going to come back to the next slide. Once technology allows me to perform, how much carbon are we really talking about? I mean, we talk about parts per million, which means if you break it down, we talk about 300 parts per million or 400 parts per million. We actually talk about this. This is a sheet of paper which has 10,000 dots of pixels, perhaps. And parts per million effectively means that the carbon dioxide in the atmosphere is those 4 dots. That's 400 parts per million translated graphically to 4 parts in 10,000 dots. So that's the real impact. But there's also this idea that one extra dot, the 5th dot, is going to impact human civilization significantly. Because that's the impact that carbon dioxide has, and that's the impact of climate change. And there are 4, and this is a book, which I've been reading about recently. It's the Carbon Almanac. You must try and get hold of it. And I have some notes from that book here as well, which I thought it's better to quote than to kind of speak about. There are 4 C's which are largely impacting this rise of carbon dioxide, and one is coal, that's burning of coal. Carbon gets trapped, sequestered, held within the confines of coal, and when you burn coal, it releases into the atmosphere. Combustion, fossil fuels, again hold carbon. When you burn them, they get released to the atmosphere. Cows, 1.4 billion estimated cows in the world. Each one belches digestive system, 100 kgs of methane on an annual basis, and methane is 84 times more potent than carbon dioxide, even if methane is 70 times less than carbon dioxide in terms of global warming potential. That's cows. And then the 4th one is concrete. And what does concrete do? Concrete conquers. Concrete is, in fact, the 2nd largest thing that is around us in terms of used by humans after water. So that's the consequence of concrete. And there are some thoughts I have on that, but maybe it's not for today. In terms of data, in the US, each citizen averages around 14 metric tons of carbon emissions, 14 metric tons. To reach a goal of net zero by 2050, we need to average 1 metric ton. Citizens of China only emit 1/3 of carbon as Americans, but because it's such a massive country with so much population, the carbon is larger. In smaller countries already like Mozambique, citizens already are less than 1 metric ton. So you have this kind of global disparity. And carbon is in all forms. For example, plants hold 450 gigatons of carbon. Humans, 2 gigatons. Humans and animals, all animals and humans, 2 gigatons, right? And that's the. But why am I telling you all this about carbon? Carbon is the point of discussion today. It's the point where we talk about environment, climate change, global warming, catastrophes, floods, fires. There's some data I have on, where's that? About, maybe it's not here, about, there's a scale that is put up that if we control certain carbon emissions. Say lesser, you will have 1.6 degrees temperature rise. If it, and the 5 scales, and if the 5th scale very high emissions, then you're going to have almost 5 degrees temperature rise by 2100 in 70 years from now, which means your children will see can see up to a 4.4 degree rise in temperature globally. Okay, next. Can I have the control back? Circularity. It begins, sorry, I have my clock here. 10 minutes. I'm not going to be able to show you things around, but there are 8 perhaps circular processes that the UN is talking about. The user, which is down there, is refuse. Stop buying, stop. It's not the only solution. Perhaps it's not an economic solution for sustainability purposes, but there's a user control that's refuse, reduce, and reuse. That's controlled by user. Then you have cycles of repair, refurbish, remanufacture. These go back into production. And then there's industries when they come, the business-to-business models where businesses get into repurposing, recycle, it goes back into production. And the underlying guiding principle is reduce by design. And that's where, that's UN using the word reduce by design, UNEP. Design, and design is significant because we are all designers. I hope many of you are, whether it's architecture, whether it's media, whether it's communication, whether it's product, whether it's a formidable space to be in because you have a degree of control, a degree of voice, a degree of perhaps engagement from, which is devoid, not always relevant to, is devoid from the act of business, which is the act of commercialization. It's perhaps what is the value that you will bring in? Your voice, your understanding, your ethical concerns, and these will drive decisions for industry, for your cities. So this talks about these 8 circular processes, and it says design influences the full life cycle of materials, products, and services, whether you use less raw material during production or anticipate lifetime extension and sound disposal at the end of use, also called end of life, right? And the idea of everything existing in a circular way is fundamental to how many industries work today. For example, when your laptop breaks down, industries will dismantle that laptop, plastics will be sent for recycling, the metals will perhaps be sent over there, the gold will be retrieved, if any, and so on and so forth. Plastics will be recycled, metals will be recycled, glass can be recycled. It breaks down. There's a matter of this, you can deconstructing it in some way and then organizing. There's the entire system behind it. But UNEP circularity approach, please look for it. So we did a studio at CEPT, and let's say it's a master studio. Students were from architecture, design, a range of backgrounds. 2 master's programs we pulled together, masters in furniture design, and we had a master's in building products and systems. And we gave them a brief. Where the global construction sector consumes significant, this is by Dumisevic, it's a research article, and we spoke about, let's look at life cycle for building construction, which is a significant contributor for global warming because of cement. And I'm sorry you can't read this very clearly, but we spoke about the life cycle phase because when you understand circularity, you have to understand life cycle. And traditionally, in terms of the built environment, we have a linear life cycle where raw material, it's material supply, production, assembly, use, end of life, and that's it. Demolition, right? So most buildings are designed for this end of life scenario where you cannot recover the parts, where demolition, and there's a kind of important note on demolition that when the building is broken down, there are almost no attempt to recover any of the constituent parts for reuse because you can't recover concrete. That's the end of it. It's landfill material, that's it. And if a building has 70 years or if it has 80, 90, you can push a life of a building. That's a human life, right? And we all live and we have cycles, generations of use, grandfather, parents. The building life is approximately 70 years if it's not impacted by urban regulations which change FSIs, change TDRs, which means that you may have a large parcel of land with lesser dwellings and an FSI may impact you in 10 years or 15 years to suddenly break what you've already made and make towers over there. And that's the nature of life cycle for buildings. And what happens to broken buildings? I do not know, but we looked at a cyclic model. And this is theoretical because it's not always possible to achieve. And that's the good part of academia, where you can push certain ideas around concepts and ideas around possibilities and ideas around, for example, cyclic models. So what was a cyclic model? Cyclic model is material supply, production, assembly, use, and end of service life. And that service life, after which we talk about dismantling and taking it back into the system. Not all materials allow for it. Yeah? So this was a larger idea of the studio. We spoke about reversible building, which means that the end of life means every component of that building goes back in the same loop where it can be reused, recycled, and has some functional role to play. It does not go into landfill. Circular design, net zero, off-grid are fundamental concepts. Net zero, and the idea of, for example, when Abhin spoke about ACUs, there are two aspects of this. One is what we call embodied energy, and one is operational energy. Embodied is what it takes to build that building. It takes the concrete, it takes the aluminum, it takes the glass, it takes the metal, steel, everything. And operational is what you will do with your air conditioning, lighting, passive cooling, or whatever. And there are two significant aspects of energy, so please don't consider one, consider both. This project, we looked at that from the net zero perspective, off-grid, and some other things, sorry. So I'll just play the video straight away, what students did. Can we play the film, please?
PB8 is the internal member that doesn't have any push.
Most compromise के ऊपर नट लगने की जगह नहीं. So what do students make? They make a building, in not my opinion, because we designed this in the first week. It's a 16-week studio. Uh, we designed an awareness of process and the awareness of all these concepts. Can you load the student presentation? Yeah, the next, we'll come back to the slide later. So I think it was intended for this not to be a design problem, like in the conventional way, because designers have this, deep interest in pushing aesthetic boundaries, conceptual boundaries. We felt that a lot of time goes in thinking about the creative act, in the act of trying to make some pretty fundamentally different works or perhaps statements of your own interests. Can you make it 2 pages per sheet, per slide? You'll have to kind of. It's important to have this, this roughness sometimes to kind of, keep it informal. Otherwise, it becomes very formal, and then there's no sense of, perhaps the lighter aspects of how we exist. I think it's going to start. All of you are studying or working in the design field, the architecture field. Is it maybe it's a chance to also connect with some of you all? Yeah, architects, designers. Oh, architects, so many. Oh, okay. Designers. Oh, okay. Wow. That's interesting. Technology. Okay. But designers means what? Like, okay, yeah. Full screen, view, whatever you want to do. Oh, it's my laptop. Okay, so you saw the video, and I thought it would be good to, in the jury presentation which happened for this project, the jurors or the audience saw the video at the end. I thought I'd show it up front because it needs to kind of go into your mind about what was achieved by students, and then perhaps go in a bit in process and what processes informed decisions the students made at that point of time. So I'm not going to get into the next. I'll just share credits. I'm Saleem Bhatri, Jinal Shah, Gautam Bhasin, Kushari Teaching Associate. Students, next. This is not working, right? No, it's not, I can't change the page. The page I can't change. Ah. So can I say next, no problem. So that's fine. So the design approaches, and this is important note, we had design for environment, which has a structure, has a framework, designed for disassembly, designed for manufacturing and assembly, off-grid net zero. There are 5 large approaches students considered. Next. So what is design for environment? And this was fundamental because you are taking theory, you're working with concepts, you're working with frameworks, and students need to kind of get a sense of that. Systematic consideration of design performance with respect to environmental health and safety objectives over the full product and process life cycle. Do note that the word life cycle will repeat. So DFE combines several topics, which is disassembly, which I already spoke about, recovery, recycling, disposal, regulatory compliance, human health and safety impact, and hazardous material reduction. And the next. So choose materials, again, fundamental. I'm going to go through this pretty fast because there are certain objectives which students used, which we used together. Choose materials which are renewable, biodegradable, and non-toxic. So wood was one option. Why? Wood sequesters carbon. 50% of wood is carbon. Wood holds carbon, right? As a tree grows, it pulls out from carbon from the atmosphere, right? It only works if the tree you cut, you plant that many more trees. We looked at wood. Do remember that we are in a time, and you can see it already, the discussion between renewables and non-renewables, between fossil fuels and the renewable energy, right? What are we doing with fossil fuels? We are taking oil and we're just taking it out. It's a one-way process. In renewable energies, there's a cyclic process. What happens, right, when the quarries run dry of stone, right? What building materials are available in perpetuity? Which building material is the one which you can grow? I'm just putting these ideas over there. You can grow wood, right? You can, and it grows by itself because it uses the natural elements for growth. So wood was selected, was also sponsored. The project became sponsored by many peers, by many companies. Next. Production. Again, students considered the impact of production. Next. Energy efficiency, there's embodied carbon, operational carbon, renewable energy, there's other factors, U value, R value, I'm not going to get into. Just giving a large structure so you get the context of what we're talking about. Next. Life cycle assessment to the entire project life cycle. So what happens when that building or that unit that students will make has no functional requirement? It can simply be disassembled, all the units segregated, and those can go back into the raw material life cycle, again, input. So there is no waste, there is no construction waste, or limited construction waste. Next. But life cycle assessment is something very fundamental, and it will come more and more into the next few decades. And you will hear about this term. Please keep an eye on this word, LCA. Recovery of and reuse of materials. You can reduce waste, conserve resources. Next. This was the approach 1. This is design for environment. Next. But then, can you design for environment and using these fundamental ideas of breaking down parts, if you have not fundamentally designed for those parts to be disassembled in the first place, which means that if you have to plan for disassembly in the design process. We design various things and we feel, okay, wow, it's going to get made somehow, it gets made. But if you do not plan for disassembly whilst you're designing, it's an active protocol in the design process to understand how will this thing, once it's made, be disassembled. And why are you searching for disassembly? Because we are saying you want to reuse materials. What happens when you glue things? They'll need to be ripped. What happens when you hammer 50 nails to join two pieces of wood? The wood is destroyed. What happens when wood gets destroyed, right? For every kg of wood that gets destroyed or gets burnt, you have 1.8 kgs of carbon dioxide going up. Design for disassembly for us was fundamental to design for environment because you are coding disassembly in the design process. So all designers over there. So next. What then are the aspects of design for disassembly? There was documenting materials and methods for deconstruction, which means that when you are thinking of designing and making, you also think of dismantling and how does a person, you will not be there, it could be 10 years, it could be 10 days, it could be 10 months, it could be 10 years. How do you inform the person who disassembles it to disassemble it in a way where all the parts are fully recovered and can be recycled? Document the materials and methods for deconstruction. Next. Select materials using the precautionary principle, which of course linked to future impact. So you're going to use certain metals, not going to use certain metals. These are studies you have to do. Next. Design connections which are accessible. You design something and to pull the structure down, if you require a crane to reach a particular level to open one joint, it is not possible. So design connections that are accessible, that's visually, physically, ergonomically accessible, which will increase efficiency and avoid the very many aspects of the act of disassembly. People will be used to disassemble your artifacts, edifices. Next. Minimize or eliminate chemical connection. I spoke about binders, sealers, glues, right? Because once you do that, that's it. That's when the entire thing becomes one. Can you disassemble it? No. The industrial glues right now, which can glue wood to metal, that's it. Next. Use bolted, screwed, and nailed connections. This is again in the concept of making things that when you use things that can be removed in a particular way, you are salvaging the material. The material can be used and the material will not get destroyed in the process of disassembly. Next. And this is linked to building. This document is focused on the act of construction and building. So what you're seeing right now is not necessarily linked to an iPhone or to a chair. It's the act of building. This is okay. And designed to the worker and labor of separation. So you need to remember that there's somebody in the future is going to disassemble this. Think about human scale, think about ease of removal, think about the labor intensity required for this, and the ability to incorporate a variety of skill levels. The person who disassembles that cannot and should not have to be an expert. Next. That comes to simplicity of structure and form, right? This is what has led to the outcome. This is not a design problem. This is a systems level thinking. Interchangeability. Okay, next. And safety construction. This is designed for disassembly. So you have the idea of design for environment, which talks about dismantling, disassembly. You have design for disassembly as concepts and frameworks. But what do you assemble next? Design for manufacturing and assembly. So we use that framework to think about lean manufacturing. We spoke about integration of product design into architecture in some way, where the building is constructed as a series of components that come together, almost like how things around us come together. I can dismantle this, I can dismantle this. Yeah. Sorry, go back. So group of design principles or guidelines structured to help the designer reduce the cost and difficulty of manufacturing. The ease of manufacturing is as important as the ease of disassembly, and this is the focus of manufacturing and assembly, because in the act of manufacturing, you also have the act of assembly. When Maruti manufactures a car, it doesn't manufacture the car, it manufactures components which are assembled and become the car. Okay, next. I mean, these are fundamental things. I'll run through this faster. I'm keeping an eye on time. Okay, fast. Reduce total number of parts. Next. Run. Modular. Next. Standard components. Next. Next. Okay. Next. Off-grid. Next. We can pass this. Net zero. Next. Okay, so this was the prototype you all saw. Okay, and I can perhaps just quickly run through this. You can go at the speed of light. We had 16 weeks, 16 days. Students, next. You can just run through everyone who contributed. We are grateful to everyone who worked with students and many people who contributed. Next, we can run through this fast. Yes, fast. All these companies, whether it's Tata Solar, whether it's rainwater harvesting, whether it's electrical, new way of dismantling even your energy systems. Next. Yes, you can, next. Yeah, you can show some of these photos quickly. The prototype in a small model, as part of the fun of being a designer, you can envisage things and, oh, suddenly then 1:1. This is in 6 weeks down the line. What you saw eventually next. All the students, we had experts coming in who joined the fun. Next, Gurdev, who designed the CEP workshop actually. Complex problems, all that stuff. Next. I think, yeah. Next. Next, you can just run through all this. I just want to give you some snap. Okay, so this is, hold on here. 8th April, in the midst of summer, in hot Ahmedabad, 2023. Next. This was a site in CEPT, right? Jury was around 30th of April. This is 8th April. You couldn't work in the day. Next. At 4 p.m., we had inserted the piles, light foundations, which hold everything, right? We researched and we found these things, and we kind of, didn't have to break the land or remove these things, lay foundations, just screw piles. We just fixed them on the ground. They were tested for load. We have Faculty of Technology. Next. And 30th April you saw, so I'm going to end over there. For this particular project, so I'm going to take 5-10 minutes more. There, you can go back to my first presentation. Just so in 19 days, the students put together this unit, keeping all the values and structures. So, for example, they used nuts and bolts. They didn't use any glue. The roof was recycled plastic. Every single component in that structure followed precisely the recipes. So that was the interesting thing, that you can simply understand what it really takes to take something, to take an idea, and without thinking too much about design, translate that into built form. It was, again, was north facing, so there was the glass was, against solar thing. Go back to the first presentation. Yeah, go back. Back. Yeah. Next. Yeah. 3 exhibitions. So one is the academic nature of the design problem and the environmental problem and the engagement that students can have with this. And then there was the practice. And the practice gets a range of opportunities. And this is 3 exhibitions that we've done for our clients, Studio Ren, very, very discerning clients, connected with the world of art, culture. They have a brand called Studio Ren. They make jewelry. Next. So this is what they came to us with. We've done 2 exhibitions, one in Gallery Mascara, one in KCC. Help us do a next one in Bombay. Yeah? Have a look. They're very beautifully done. So we know the designers who've done them. They're beautifully done. But I'm trying to look at the aspect of exhibition or temporariness or transience that the power of design sometimes, needs to address. A lot of materials, a lot of panels, a lot of floor levels, lights, everything. Metal structures, enclosures. To display, what is a display? Perhaps what fits on this table. We're talking about jewelry. Yeah? But that's okay. That's the nature of exhibition. You want to build something of consequence. You want to make a statement. You want to have a voice. Next. So they came to us with poetry. They came to us with some values, some thoughts, things about growth instead of construction was said. We responded back in poetry, lost in abstraction, ephemeral, all that. Next. Waste, life cycle, circularity, core to us. Exhibition waste. If the exhibition is modular, it's repetitive, there's no waste. If the exhibition is bespoke, custom, right? Custom design stands. Very high chance of waste, very high. In trade fairs, this is actually more about trade fairs because the scale is at that degree. Next. So what we do is actually a drop in the ocean. If you like to believe anything otherwise, it's a fallacy. Even with our decent level practice and thinking as designers, whatever you do will be a drop, but all of it together, it becomes the ocean. This is a drop in the ocean project. I don't think it has any significant environmental impact, but it will show you approaches. Next. Exhibition 1. Lens of circularity. Let's go back next. Circularity, transience, precious. The jewelries were precious. The diamonds and precious stones. And priceless was what we imagined the space to be. And we'll come to that. Materiality, local sourcing, end of life. We'll see what this means. Return to earth. Nutrient-rich soil for planting and rice to feed birds. Exhibition, what's happening? So the apparatus, the exhibition apparatus we felt would merge and dissipate into the natural, and the objects on display, which is what the exhibition is for, would exist in perpetuity. If you go back one slide, you may want to read it, but let's go ahead. We have no time. Next. Primal, this is the first version. Next. So we use earth. Instead of making rigid metal ply stands, so let's use earth. But can you use earth which is stabilized? What happens? And can you use, and when the exhibition is time, which means the person is renting the gallery for that particular day, which means you only get a night prior. And how do you make earth blocks in one night? You can't. Then you make earth blocks elsewhere. But if you make earth blocks elsewhere, and if you don't if you don't bind them or glue them with cement, then they're going to collapse in the truck because you need to carry them up, take them in a truck, drop them over there, and then if there's no cement, it collapses. Cement is glue. So a team spent 2 months in making this, figuring out the right recipe to hold a block of soil with various natural fibers and certain other recipes so that we can make it in our workshop, take it by truck to the site and suffer all the Bombay potholes because western monsoons. Next. This was the exhibition. By the end of it, right? Because there's no cement. And we thought, let's have some fun if we're not putting cement, and let's show that we can make the soil even more nutrient rich than it came to us. Next. Next. One block broke on the way. We became a centerpiece. Next. Next. So you see what's happening to this block over on the right? We said we're talking about this 10-day exhibition, and if we're talking about it being, sensitive to the environment and not using cement, and is it nutrient rich, and what happens if we put seeds into the blocks? And what are the seeds on the 10 days of the exhibition? Something's happening to the blocks on the bottom right. Next. There. Proof of concept. This can go back to earth and can create life. It's not killed. It's not. And we let those blocks grow. 10 days from there to there to there, or maybe maybe in the last year, they were living, right? Next. That's one over there. Next. We said, okay, let's get some trees inside. Let's go to a nursery. Let's make the space active. We're talking about nature. Let's see how we can put trees. And we planted these trees at the end of life. So every single thing in this exhibition was defined for end of life. The trees were planted in certain areas. The mud went back to landscape. The bases were recycled ply from lost packaging, which went back into the packaging cycle. And the clients had asked us to kind of put some kind of felt on top. Sorry, I'm going to take some time. I lost some 5-7 minutes. And the felt, we said, no, it doesn't work. You can't put these beautiful blocks there and then you make them and you put felt to keep the jewelry because that will, scratch the precious. So we said, let's put the jewelry on rice and let's give the rice to the birds. Not much, 5 kilos. Next. 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 Inside, outside, yeah. The rice, the jewel, some of the jewel, there were bamboo stands were made, and what was kept on the top was on rice. Next. We also made cards to give for invites, and we used the same earth, residual earth, to make those cards. Next. These were the invitation cards for Primal. Next. Made everyone different, made by our team in the studio. Next. And we also gave a pot with it. And the pot was not kiln fired, no energy cost. And the pot, you read the last sentence, you can read it. The earth pot is designed to eventually disintegrate. At that time, you can place the entire pot into another pot of your choice. It will become the earth. Because this pot it's a compressed earth using some kind of resins, it's bubble, certain natural resins. Okay, next. 2. We had this long table in our studio. We cut a beam for something for our architectural thing, and we use it as a table. It's 14, 15 feet long. Yes, I'm sorry, I'm going to take 5-7 minutes more. It's shorter lunch. Okay. Quickly. Stone from our site. right? Table from our furniture, from our own furniture, and stones from our sites, waste stones. Life cycle, the table came back to us, and the stones went back to landscape. Next. This was in Delhi. Next, next, next. And the beautiful. And the aesthetics of form, aesthetics of. So you have to understand that if you keep your principles and your intent clear, the world opens up. Next. Zero waste exhibition. Next. Next, 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 next. This was 3 stands we used for Venice. The Venice Biennale, we were invited in 2018. We had those stands with us lying in our stores. We just used them. Next. Next. 3. Last one. Okay. Collaborator eventually. Next. We were looking for something of the same form and shape as to keep the jewelry. And we thought, let's keep on cotton bales. Next. There were compressed bales which had. Next. So what were you talking about? One sentence. Carefully selected material from extraneous ecosystems is momentarily held in transit. Whilst the jewelry collection is set within a compaction, let's not get that. Using existing forms in the logistics of industry, use it, host it, and give it back. Next. Zero waste. The same cotton bales we borrowed from a vendor, we had the exhibition, and we gave it back to him. Okay? It was a stunning exhibition, an experience in material and just the next. This is cotton bales. Next. 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 Primal 3. This is just recent. Next. Next. Recapping and run through fast. Next, 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 next. Next, next. The concepts for the structured academic thing, the concepts for what we did as a design studio. Next. Output. Thank you so much. I'm sorry about the technical delays and my delay subsequently.
Not at all, Saleem. I think the problem was at our end.
No, not at all. This is not at all. This is not on us. I mean, I'm pretty happy to have such situations. That's what design is for, to solve such things.
Yes. Thank you so much, Saleem. And I think.